Today we're going to be talking about finding the rational roots of polynomials. By the end of this video, you should be able to use the rational roots theorem to determine the rational roots and factors of a polynomial, and you should be able to write an equation of a polynomial given the rational roots. So first, let's take a look at this graph of a polynomial. We're asked, what are the roots? Remember that roots are the same things as zeros, solutions, and x-intercepts. So our x-intercepts are -3, -1, and +2. So when you write the factors of the polynomial, remember when we did factoring, if you had that x equals -3, the factor is x plus 3. So the factor that gives you the answer x equals -1 is x plus 1, and the factor that gives you x equals 2 is x minus 2. Now, if we do not know any of the zeros of a polynomial, so if we don't have a graph, we can create a list of possible rational roots. Which we can then use, along with synthetic division, to find all of the roots, or zeros. Just a reminder, rational numbers are numbers that can be written as fractions. So this list will give us some integers as well as some fractions. So the rational roots theorem says, if you have a polynomial with integer coefficients, then every rational zero of that polynomial has the following form: P over Q, where P are the factors of the constant and Q are the factors of the leading coefficient. So let's take a look at a couple of examples. So for these first two problems, we want to list all the possible rational zeros or rational roots using the rational roots theorem. So we need to know what the factors of the constant are and what the factors of the leading coefficient are. So in this first example, the constant is 12. So we need to list all the factors of 12. So 1, 2, 3, 4, 6, and 12 are all factors of 12, as well as -1, -2, -3, -4, -6, and -12. But we'll add that in a minute. The leading coefficient is 1, and the factors of 1 are just 1. So the rational roots theorem says that we need to divide all the factors of the constant by the factors of the leading coefficient. So 1 divided by 1 just gives us 1. And I'm going to stick a plus or minus in front of it. That way we don't have to write out both +1 and -1. 2 divided by 1 is 2. 3 divided by 1 is 3. 4 divided by 1 is 4. 6 divided by 1 is 6, and 12 divided by 1 is 12. So all of our possible rational zeros, and not all of them will actually be zeros of this polynomial, are listed here. +1, +2, +3, +4, +6, and positive and -12. So let's take a look at another example. Our constant is -10. So the factors of 10 are 1, 2, 5, and 10. Our leading coefficient is 4. So all the factors of 4 are 1, 2, and 4. So this one's going to be a little bit more complicated. We need to divide each of the factors of the constant by each of the factors of the leading coefficient. So we need to do 1 divided by 1, which is 1, 2 divided by 1, 5 divided by 1, and 10 divided by 1. Those are the easy ones. Now we need to do 1 divided by 2, which is 1/2. 2 divided by 2 simplifies to 1, which we already have in our list, so we don't need to write it again. 5 divided by 2. 10 divided by 2 is just 5, which is already in our list. Then we have 1 divided by 4, which is 1/4. 2 divided by 4 simplifies to 1/2, which we already have. Then we have 5 divided by 4. And 10 divided by 4 simplifies to 5/2. So that is our list of possible rational roots. So you might be thinking, how is this helpful? But we're going to put that together with the fundamental theorem of algebra and synthetic division and be able to figure out all the roots to a polynomial. So the simplified version of the fundamental theorem of algebra says that a polynomial has the same number of roots as its degree. Some of the roots might be real roots, some of them might be complex roots, but whatever number the degree is, that's how many roots a polynomial has. So, using the fundamental theorem of algebra, we can look at these next two polynomials and figure out how many roots or zeros they are going to have. This first one is already written in standard form, and remember that the degree is the highest exponent, which is 4. So that means that this will have 4 roots. The next example, the highest exponent is 7. So its degree is 7, so it has 7 roots. Now let's use this to find the roots. So we are going to list all possible rational roots and then find all the roots. So just like we did on the last couple of examples, we're going to list out all the factors of the constant and the leading coefficient. So our constant is -20. The factors of 20 are 1, 2, 4, 5, 10, and 20. Our leading coefficient is 1. So when we divide these, we get positive and negative 1, 2, 4, 5, 10, and 20. So that is our list of possible roots. Now, how do we figure out which ones actually are roots? Well, in the last video, we talked about synthetic division and how if a number is a root, then you end up with a remainder of 0 when you do synthetic division. So we're going to do the same thing here, except instead of being given a root, you are given a list of 12 possible roots, and you just kind of have to go by trial and error until you get one that works. So if you pick one and you do synthetic division and that one doesn't work, then you cross it out and you pick another number and do synthetic division until you find one that is a root. So let's set up our synthetic division. Our coefficients are 1, 5, -4, and -20. I'm going to draw my L. And then I need to pick a root that I'm going to use for my first guess. And I'm going to pick 2. So remember, when you do synthetic division, you bring down the first number, then you multiply the number outside, so 2 times 1. Write that number in the next column. Then you add 5 plus 2, multiply 2 times 7, add -4 and 14, multiply 2 times 10, and then add -20 and 20. So I get a remainder of 0, which is what I want. So now I'm going to write out the quadratic that I'm left with. I started with a cubic, so I know that after my synthetic division, the answer is 1 degree lower, so it's a quadratic. And these are my coefficients. So I have x squared plus 7x plus 10. And then I want to factor that. This factors to x plus 2 and x plus 5. So my roots are -2, -5, and don't forget the one that I found by synthetic division, which is 2. For the next example, we're going to do the same process. We're going to find the factors of our constant, which are 1, 2, 3, and 6. Then we're going to find our factors of the leading coefficient, which is 1, and divide them. So I end up with positive and -1, 2, 3, and 6 as my list of possible rational roots. So that leaves me with 8 choices. So I'm going to go ahead and set up my synthetic division. My coefficients are 1, -2, -5, and +6. Draw my L. And then I'm going to pick a root to start my synthetic division with. I'm going to pick 1. So I start by bringing down the 1, multiply 1 times 1, add -2 and 1, multiply 1 times -1, add -5 and -1, multiply 1 and -6, and add 6 and -6. So again, I end up with a remainder of 0, which means that 1 is a root. Since I started with a cubic, my answer to synthetic division will be a quadratic, and these are my coefficients. Then I just need to factor and solve. So my factors are x minus 3, x plus 2. So my roots are x equals 3, x equals -2, and don't forget the one I found by synthetic division, x equals 1. So that's how you use the rational root theorem and synthetic division to find the roots of a polynomial. We have one more thing to talk about. You can write the equation of a polynomial if all you know is the roots. The directions say, write the equations for f of x given the following roots of the equations. Your equation should be in standard form with integer coefficients and of least degree. So that means we have 3 roots here, so our degree is going to be 3. Now, we already talked at the beginning of the video about how to take a root and write its factor. So if I have x equals 3, then that means my factor is x minus 3. If I have x equals -2, then my factor is x plus 2. And x equals 1, my factor is x minus 1. And this will give me f of x. Now the directions say that it needs to be in standard form, which means that I need to multiply these out. So I'm going to start by double distributing the first 2 factors. So I'm going to do x times x gives me x squared, x times 2 is 2x, -3 times x is -3x, and -3 times 2 is -6. So I'm just multiplying these first two together. Then I'm going to go ahead and simplify this. And I end up with x squared minus x minus 6. Then I'm going to bring down the other factor. Now I'm going to double distribute again. So I'm going to multiply each of these by x and then each of these terms by negative 1. So first I have x squared times x, then I have negative x times x, negative 6 times x. Then I'm going to multiply all these terms by negative 1. So x squared times negative 1, and I'm going to write this underneath. Gives me negative x squared, negative x times negative 1 is x, and negative 6 times negative 1 is positive 6. Then all I need to do is add my like terms. So I end up with x cubed minus 2x squared minus 5x plus 6. And that is my equation. You can check your answers by taking the calculator, going to y equals, type in the equation that you got as your answer. So this graph gives us negative 2, 1, and 3 as our roots, which is what we were given at the beginning of the problem. Let's try one more. Now these are a little bit trickier because we have some fractions as roots. If you have the root of 1/2, your factor is not x minus 1/2. Because if you use that, you would end up with a whole bunch of rational numbers as your coefficients, and you have to have integer coefficients. So we're going to take the denominator and slide it out front. And you can see if you set that equal to 0 and solve that will still give you x equals 1/2. So that is going to be our first factor. X equals 4 gives us a factor of x minus 4. And then for negative 1/3, we need to do the same thing that we did with the 1/2. Slide the denominator out front, and we get 3x plus 1. So now I'm going to do the same thing. I'm going to pick two factors to multiply together first. So I get 2x squared minus 8x minus x plus 4, which when I combine the like terms, gives me 2x squared minus 9x plus 4. Then I'm going to bring down the third factor. And multiply everything out again. 2x squared times 3x, 6x cubed. Negative 9x times 3x is negative 27x squared. And 4 times 3x is 12x. Then I need to multiply all the terms by 1. So that gives me 2x squared minus 9x plus 4. When I combine my like terms, I end up with 6x cubed minus 25x squared plus 3x plus 4. And again, you can always check that on your calculator to make sure that it works out.